This is the CS790 antenna from Convergence Systems Limited. At only 6 millimeters, it is the thinnest UHF antenna on the market. CSL claims that it's unlike any other antenna in the world and can be placed on any type of surface, including wood, metal, or plastic, making it suitable for shelves, drawers, or even enclosed metal areas. Hi, I'm Lou Sirico, and in this edition of the RFID Network, we're going to put that claim to the test and see just how well the CS790 really performs. Stay tuned. Welcome to the RFID Network. I'm your host, Lou Sirico. In this edition, we're going to take a look at the CS790 UHF antenna from Convergence Systems Limited. The 790 is designed to work with EPC Global Class 1 Generation 2 and ISO 18006C compliant RFID readers.
These antennas are specifically designed for use in display cases and cabinets, on desktops and shelves, with conveyors, or even floors, ceilings, and walls. What makes these antennas evolutionary isn't just the 6 millimeter thickness. These antennas can also be placed on any type of surface, either metal or non-metal. They are made of an extremely durable plastic material that you can walk on or even push a cart over. Plus, the length can be cut to fit whatever dimensions are required, which provides the ability to easily retrofit into existing environments. Most importantly, unlike other UHF RFID antennas, these antennas have an evanescent antenna pattern, which reads RFID tags directly above the surface and with better control than any antenna our team has ever used before. These features allow RFID technology to be used in ways that were previously very difficult to implement or simply cost prohibitive. The thin antenna has a fixed width of 250 millimeters and is available in 3 standard lengths: 360, 700, and 990 millimeters. Custom lengths can be ordered in as little as 10 units. You can also specify which side the cable comes from, as well as the cable connector type, either SMA or SMC. The antenna comes with a metal backing for use on non-metal surfaces, or a plastic backing for use on metal surfaces.
Here we are doing performance testing of our CS790 thin antenna. We've placed the thin antennas on these metal shelves and connected them to a CS468 reader. Each of our binders have RFID tags in them. What we're going to do is test to make sure that the metal shelves truly do isolate the read zones so that we're not reading binders in different shelves. Let's take a look at the results.
All of the thin antennas are connected to a single CS468 RFID reader. This reader supports up to 16 separate antennas and allows you to control the power, queuing algorithm, and polling time individually for each antenna. Power can be increased to accommodate for long cable lengths. By adjusting the transmit and receive power, the evanescent antenna pattern provided remarkable isolation between the metal cavities. When we place 2 thin antennas next to each other, 30 to 60 centimeters, that's 1 to 2 feet, is needed between them if you want to prevent cross reads. The best performance did not require having an antenna on the side of the shelf, but was actually achieved by using a single antenna placed horizontally directly on the shelf. As binders were removed and replaced, we experienced minimal stray tag reads between the shelves, and those were easily filtered out by our Omnitrol software appliance. The Omnitrol appliance is the first software platform to fully support the CS468 16-port reader. The Omnitrol software allows you to configure, manage, and monitor multiple readers and antennas from a single point and integrate the tag data into intelligent services running on the appliance or with your back-end applications. Through the Omnitrol appliance, you can send your data as ALE reports or EPCIS captured events. To really understand why the thin antenna is so evolutionary, it's important that we explain how it compares to other UHF RFID antennas.
In front of me, there's 4 different types of antennas. This is a far-field circular polarized antenna. This is a circular near-field antenna. This is a square near-field antenna. And this is a very thin, evanescent RFID antenna.
Far field patch antennas are normally too thick to be placed on a shelf. This is a very simple two-dimensional model of the antenna pattern. It typically is shaped like a balloon or a cigar. The more technical professionals in the RFID network audience would be very disappointed if we failed to show that there are actually side lobes at the base of the main lobe. These side lobes further demonstrate the difficulty in using a patch antenna for a shelf application. Near-field antennas are also a little thick for shelf applications. Although they have an advantage over far-field antennas in that they can read RFID tags submerged in water, to read all the tags on a long shelf, multiple antennas must be placed side by side, making it complex to design and cost prohibitive in most cases. They also require the use of an RFID tag that has a loop, which not everyone uses, especially in retail applications. The thin antenna is a far-field antenna that works with any UHF RFID tag. Given the 6 mm thickness, the ability to be cut to any length, the durable material, and the very controlled antenna pattern, it truly is the best alternative for shelf applications. We've provided a lot more detailed information on antennas in our accompanying article, which also features in-depth diagrams and equations. CSL offers each of the thin antennas as part of a development kit, which also includes a 16-port RFID reader. You can even get a kit with a variety of antennas. For more specific information on the kits, click on one of the links next to this video or visit the RFID.net website.
That wraps it up for this edition of the RFID Network. If you'd like more information on any of the products you've seen, please visit us on the web at rfid.net. Thanks for watching.